you recall, we've been exploring our driving question. How was this place on Earth going to change over 10, 100, 1,000, 10,000, or even a million years? And so what we did today is that one of the questions we asked to help us to figure out the answer to our driving question was, what does water actually do when it interacts with Earth's materials? And so you had the opportunity to build various landforms in your stream tables to see how water actually interacts with the land on your various landforms. And what I want you to do right now is to share with the group what happened. What were your observations based upon how water interacted with your landform? So, Amy, would you like to share first of all what your group observed?
Sure. Okay. So these were our results. What we noticed, we didn't want water to affect the land in rain. We wanted it to be affected by a water source. So we have a reservoir that kind of had the water up at the top, which we realized we needed to add it to our model. We were thinking about, gosh, I guess rivers don't really start really small like that. There's something larger, at least that's what we noticed in our model. So as we moved forward with our model, we noticed that in our prediction, we thought 2 areas would become larger, and they did. But what we didn't account for was that a new path for the water to take would come out as well. So we noticed a new river, like where there was not one before, a new river had started here, and where there was not one before, a new river had started here as well.
When we think about how the water interacted with the land, how would you describe the behavior of the water?
So we talked about how gravity had an effect.
Can you tell me more about how gravity had an effect on the water?
So what we did is we took our stream table and we propped it up so it was more slanted. And then as the water was coming down, we noticed that as it was coming down, gravity was pulling it down.
Gravity pulled your water. Okay. And as gravity pulled your water, what happened with the land?
As the water was coming down, the land was moving. So what happened was the sand was traveling down with the water. I didn't really notice it, correct me if I'm wrong, I didn't notice it moving to the side. It was actually moving down the stream table. So it was like taking sand that was way up here and it was bringing it down with it.
So water moved the sand. Thinking back of the analogies that we used earlier, of those analogies, which one would you use to describe how water interacted with the land in your landform?
So it left some sand behind, but it took some with it. So my analogy would be like what we talked about earlier with the scraper, because the scraper's not getting all of the ice, it's taking some of it with it. You hit a little bit more, it takes a little bit more. You hit a little bit more, it takes a little bit more.
So it takes little bit by little bit? Is that what you're saying?
Yes.
What about the other groups? Did anyone observe that type of activity or interaction in their landform? The scraper.
I think that ours was a combination of the scraper and the broom, because it did seem at times like it was just picking away, but then at one point it seemed to all give way in a sweeping motion.
So you're saying that your land was released in one
It seemed
swoosh.
like maybe it was how compacted it was to begin with, because we had the gully and it was completely dry to begin with, and it was just a dry, solid land with really strong banks.
And what landform did you all have?
We had the gully.
So tell us more about what happened in your landform.
So we originally predicted that it would just get a little bit wider and a little bit deeper, kind of like equally dispersed over time. But what we found was we decided to think that we actually lifted up the tray so the water could flow downwards, maybe from the mountains. We weren't really sure how the water was going to the water source, but we started at one point, and when the water flowed downward, it actually took out the complete, instead of it being at a slant, it completely took out the bottom, and the banks kind of stayed intact. It didn't really erode the banks as much as we originally thought. So it did get a little bit wider, but it mostly got just deeper and almost flattened out at the bottom.
I'm trying to make sure I understand you. So you're saying that the water moved the sand down the gully? Okay. But you said it did not impact the sides, am I
Not
correct?
as much as we thought it would.
Okay.
They stayed pretty intact. They stayed more intact than the rest of the riverbed.
I want to go back to what you said. So you said that the water moved the sand down to the gully. So how did that affect your gully in regards to where did the sand go?
The sand, well, some of it stayed, but some of it moved with the water downwards towards the bottom of the stream table. And I think a lot of it had to do with how isolated the water flow was. It was coming from one source at the top of the
Okay,
river when
okay.
it flowed down.
Okay. And what about your group, Kiera? What, you had the dune, okay?
We had the dune. So we actually had to use dry sand to make ours. So we had damp sand on the bottom, and then we had to use dry sand to make the dune. And so our prediction was that the peak of our dune was going to sort of wash away and then give way to these channels. When we poured the water, we used the water cup with the multiple holes in it
Okay, right.
right over the top of the dune to simulate rain. And so what I noticed, talking about the analogies, when I'm looking at it, for me, what I observed, and if you chime in if you saw something different, but because our sand was dry, before it actually moved anywhere, it didn't give way until a certain area became completely saturated, and
Okay.
then it started to move, which makes me think of the building block sort of analogy.
Oh,
How it had
okay.
to pile on top of each other first, it collected there. And then, to me again, when we actually did the second round of rain, because we wanted to see, we didn't have, the first time we poured our water with our rain, we didn't have as many channels as we thought, so we did a second round to see what would happen if more rain came. We had a little bit of a channel come, but then there was this sort of sweeping, or almost like a slide, where that center channel just sort of like all slid down to the bottom. We had a huge sand deposit at the bottom.
Sand deposit.
At the very bottom of our sand dune. All of that sand that we had, it sort of just slid all the way down. So it made me think of the building block and the slide when we combined when we looked at our first trial versus our second trial.
So you've described how the land changed. How about the water? How was it interacting with the land?
So we used that rain source, and it collected. It saturated the dry sand,
Okay.
and then once it was fully saturated, the excess water then began to move the sand down to the bottom of the sand.
So
dune.
the
From peak
excess
of the
water
sand,
moved
from the peak of the sand dune all the way to the bottom.
down. Okay. So it actually sounds like more than one of these analogies can be used to describe how water interacts with land. Would we agree?
Yes.
Well, let's take a closer look at how water and land interact. Okay, so that was a video of an actual river and how water interacts with the land. Tell me, what were some of your observations? What did you see?
Sand just dropping down, just slide, kind of like what you said with the slide, it just slid right down and in.
And when it dropped at the bottom? Immediately did it drop?
It didn't seem to travel with the water, it seemed to just drop down.
Okay.
Notice water levels changing, so sometimes there's more water, sometimes there was less water, and it seemed to, I'd have to watch it again, but that seemed to make a difference when the water level changed.
Why
That
do
the
you-
land also changed.
Why do you think the water level changed? What could have possibly caused the water level to change?
Rain or melting snow from a mountain.
Okay.
I'm wondering if the sand that's below the water level was moving as well, like sand that we could not see that caused us to see, so that the sand that Amy saw just drop into the water. I'm wondering what made, there's something underneath there that must have given way, so I'm wondering if the water is moving the sand that's below
Same
the
below
water
water
level.
is moving.
And I feel like the video kind of explained what we saw with the gully. Like we saw some of the sides and then all of a sudden when the water or when the bottom dropped out, it just flowed and the sides didn't really change, the banks didn't change anymore.
So once again, we have the sand drop down. Any other observations?
I think the water changes the consistency of the sand or makes it loose.
Tell me
Causes
more
some of the
about that.
particles to kind of break apart.
So you're saying water breaks apart the sand?
Oh, yeah. I would
Okay.
say.
And what then happens with the sand that's broken apart?
I think some of it moves along with the water, but then
Okay.
some of it stays. Kind of thinks about, makes me think about rocks and how rocks break down.
Going back to our analogies, which one would you use to describe what happened in that video?
Maybe the pool balls.
Okay, pool balls. And
How they're kind of, when one pool ball hits another, that causes the pool ball that maybe wasn't moving beforehand to now move. So maybe if it was just resting and then a pool ball that's moving represents the water, and it hits the pool ball that wasn't moving that's representing the sand, that maybe that makes it
oh,
move.
wow. Okay.
And the other connection I made with the pool balls was, in ours, we were talking about like the path of least resistance, and that water is just gonna kind of move in the best way that it possibly can. And that kind of reminds me of the pool balls as well, as like they're gonna move in their path of least resistance until maybe it hits one or something, and then it changes the path and changes the path of the other as well.
Anyone agree? I mean, or disagree or agree or add on to what
I
Kendra said?
definitely agree with that, especially thinking about the meandering rivers, when you think about the path of the water bouncing from the different edges of the land. So once it hits that wall, that goes the opposite way. So kind of like you see the pool balls bouncing on the sides of the pool table. The same with the path of the water is bouncing from side to side, and that's why you get the deeper edges there, the curves there.
Could any other analogy be used to describe what we saw in that video?
Possibly the scrubbing, so thinking about the sand that's underneath the water, that's moving possibly a little more slowly. The water sort of scrubbing away at the sides of the river.
So water scrubbing away sides?
Because again, you're not doing it super harsh, but if it's over time,
Oh, okay.
if it's wearing away at the
Over
sides,
time.
that's what's gonna get that big drop underneath, because it's gonna slowly eat away at the sides of the river.
The ice scraper again.
Oh, okay. And why? What's your evidence?
Well, sometimes when you're scraping the ice, parts of it come off, but then you get a really great one and just the whole sheet will come off. And you're like,
Oh, yeah.
yes. And that's what it happens like with the water when, after it hit the saturation point and then just collapsed, that whole part came off.
So water scraping sand either collapsed. Any other observations? When we think about the behavior of the water and how it interacts with the land, we've said that the water was hitting the sand, it was scrubbing the sand, it was scraping the sand. Well, scientists use a particular word to explain this type of interaction, and that's called erosion. And then when we talk about the land, we talked about the sand dropped down, and the sand below the water is moving. When the sand is moving and it is moving further along, either it's moving at the bottom of the water source or it could be moving further down the water source, that is called deposition. Thinking back to what we saw in our stream tables, we just talked about the processes of erosion and deposition. Do they always occur together?
Well, the land has to come from somewhere.
Okay.
But, looking at the dunes up there, it's a desert where there's not a ton of water. So I wonder if water made those dunes or if something else made those dunes.
Off of that, erosion doesn't always have to occur with water. our focus is water, but, you know, so erosion is, the land, or the pieces of earth moving away from the land. So then that earth has to go somewhere. And so in order for it to go somewhere, that's your deposition. So like you're saying, so whether it's wind or whether it's water, I think the two they have to go hand in hand, because once it erodes, where's it gonna go? So whether how far it goes, or it might move away a little or move away a lot, but the way I understand it, it has to go somewhere. So that's
There's a starting point, as you mentioned, and then there's an ending point.
Right.
So our definition, is that our definition of erosion up there, or is that just our definition of erosion for?
That is how scientists define the erosion, the scouring away of the land by water.
Okay.
But it doesn't.
Does it have?
But
to
it doesn't always,
water?
correct,
Okay.
it does not,
Okay.
it could be wind,
Okay.
yes. Anyone else have any different thoughts or anything they'd like to add? Thinking about what you observed in your stream tables, I want you to take the new data that you have collected and go back to your tables and revise your model. And when you revise your model, I want you to keep in mind to identify where did you see erosion occur in your landform, and where did you see deposition?
So really quick, can I just say, that was such a testimony to why we don't front load vocabulary.
Yeah, because you all came up with
The
it.
whole time we were doing that, I was like, oh my God, like that is what we need teachers to see. You don't need to front load erosion and deposition when they experience, and then they have something to, and we talk about it all the time, to hang that vocabulary on. So I thought it was great. I'm sorry, I just wanted to say that, because it just, we talk about why we don't front load, that's exactly why.
Yeah, and even, you could even expand on that and have after she identified those pieces, have the class collaboratively come up with, okay, so if we talk about erosion, how can we make a sentence that describes what erosion is, and have the class come up with a class definition? So to your point, rather than saying, oh, this is the scientific, let's come up with our definition from our experience, from the things that we've experienced today, that says what we say erosion is and what we say deposition is. And then, because later in the unit, they do talk about other kinds of erosion besides just with waters.
To investigate how water impacts the land on our local place, we are going to do an investigation. So I want to call everyone up to the front to see what we have put together. In our stream table, we have put together a physical model of Belle Isle. And I want you to take note of what the land looks like at this particular moment. And then, Kiera, would you come and add water to our model? And as Kiera is adding water to our model, pay careful attention to how the land is interacting with the water. Oh. And if you like, you can take a closer look. Here, we can have some more water. Yes, ma'am. Oh, I'm in the way. Sorry.
Oh, we just went to Renaissance Center.
Okay, you can return to your seats, and I want you to talk with your neighbor about what you observed. Kiara, I want to begin by asking you a question. I noticed that for our model, you did not pour the water directly on top of the land, but you poured the water on the outside or surrounding the land. Why the change?
So I poured it at the back so that the water would simulate or represent the river. And so
Okay.
instead of a rain source, we have we're seeing how the river affects the island.
Okay? So the water in this physical model represented the river and how the river actually interacts with the land.
Yes.
So what were some of the observations that you made? What did you notice?
I made a connection with what Kendra and Amy said earlier. They had said that it seemed like the water was flowing in a certain direction because of the shape of the island, kind of coming to a point. And then seeing Kira pour the water, it just reinforced that idea that, oh, it must be what is happening with the water. It's coming, the direction of the water is coming one area. So I'm just connecting with the learning from earlier.
And then Amy had said that in our initial conversation, we thought that that point was because the river was shaping it, was like cutting away at it, creating that point. But then Amy noticed that the water wasn't really affecting the front of it very much as it was the outer sides, the wider sides of it. And so we discussed and thought maybe that was deposition, that the point there was created through taking away of the sides of the island and putting it at the front, that maybe that's what was causing the point rather than the water eroding it.
And that actually builds on what we were just saying. Where is the sand going? We see it moving, but it's getting more narrow. So that kind of explains it if that's what's happening.
Any?
Oh, I'm sorry. And so, and when we were discussing it, we were looking at the island and we were looking at those pieces from the back end coming forward, but we're also noticing that land from the sides, so in this instance, it would be Detroit and Canada, that land, because when we were first initially looking at the model, the path of the river was very clear. We could see the bottom of the stream table, but now there's also land coming from Detroit and coming from Canada that we noticed was sort of moving up against the island as well. So deposition from those sides of the river are moving and collecting on the island as well.
And how was that impacting the island?
So, well, we talked about it's taking away from the island, but we're noticing that it's also collecting on the edges of the island. So that could also, again, be adding to the land. Where is the sand going? Where is it moving? We're noticing that it's moving away from from one source and moving towards the island as well, adding land to the island, potentially.
Any other observations? Well, going back to our lesson question, how can erosion and deposition impact our local place? What can we say? How can we answer that question? How does erosion and deposition impact our local place?
Well, we're definitely seeing that erosion and deposition changes the shape of Belle Isle over time, over a long period of time, it seems.
And not just Belle Isle, but the
surrounding areas.
It was kind of a joke.
Yeah.
There goes the Renaissance Center, but
Right.
seriously too, it's probably more like Shea Park. But you know that's cutting away at not just this land that's there for recreation. We might lose that over time if erosion is causing it to go away, but also looking at our surrounding areas as well that it might impact.
Any other thoughts?
It doesn't speak to it, but it also makes me wonder about the foliage, like what's happening to the grass, what's happening to the trees. We didn't get an answer to that in this model, but it makes me think about that.
That's a good question to put on our driving question board, Amy. Any other observations or questions? The activity that we just performed in your classrooms, you can either perform it as we did today as a group, or you have the option of actually having your students go back to their stream tables and conducting this observation, them actually creating landforms in the shape of Belle Isle and carrying out the investigation.